Imagine your production service just threw 500 errors to 3,000 users, and you only noticed it 4 hours later. The cost of it? One sprint, 4 angry customers, and a weekend on call. Today I'm going to show you how to spot the same bug under 60 seconds using just the logs AWS hopes you never turned on. With 500 errors, of course your job is to avoid them, ideally prevent them happening. However, it's not usually the case. You can't test everything. Sometimes how to secure anything might happen, and you want a way, if you're not able to prevent them, to quickly respond and troubleshoot and fix them. So you need to keep continuous eyes on your response codes and be able to react promptly. So the first way how you can make your services more reliable is to have your ingress or load balancer logs enabled. If you have the logs enabled, you have the observability. Even if you spotted it 4 hours later, you can go with the logs and see. However, to make it even more better, you can spot it right away or even before it happens if you configure alerting on your logs. So for smaller level applications, I'm usually configuring alert for every 500 because in my opinion 400 should never happen in normal circumstances. If 500 happens, it's definitely something out of order. It requires human intervention. For larger scale application, I might not configure alerting for every 500 because you might start getting lots of them and your communication channel will become noisy, and it will result of you or your team ignoring those messages because of the noisy channel. So I would configure it as a rate. So if the rate of 500 codes out of all response codes is more than 5%, you doing the alerting and it requires immediate troubleshooting. So if you had the logs enabled, you can configure alerting, you can configure notification either to your Slack channels, to text messages, pager duties, whatever. So with having that, you will be able to react promptly. Now imagine the same thing happens with 500 spikes starting to occur and you start getting notification immediately. You or your team just hands-on jump into the problem, see the issue and make the fast fix. Of course, it might require a couple minutes to troubleshoot. In the lower scale, in the higher scale site reliability engineering, they have specific processes to be able be responsive, reactive, promptly on things like that. But for medium scale, it might require some time, but at least you'll resolve issue in 10 minutes or maybe less. However, there are also ways to prevent this issue happening using the same method. So if you have your logs enabled, you have observability of everything that happens. So you can either review the logs daily, figure out which status codes, which requests happening, and you might find any interesting patterns there, or you can set up the alerting system with multiple triage level. So if the 500 rate becomes huge, it's super urgent level requiring immediate attention. If there is occasional 500 here and there, it's just you get notifications somewhere, but it's not necessarily something that distracts you from your work. So you can just have a scheduled routine every day, review these notifications and see. Why? Because the 500 might indicate that there is some malfunction in your system. If you paying attention to these rare small 500s that are happening from time to time, and you taking actions to solve them, obviously, it will prevent you from bigger disaster happening. Because what if suddenly this 500 has a root cause that's hidden in another issue? So you will find the root cause before it will take an effect. If you could continue ignoring it, the next release might collate the issue and you'll get the 500 spike that you can stop while not be able to prevent. So by taking care about your logs and reviewing them regularly will help you to not just fix issue rapidly, but also prevent them. Because think of this, if your application is accessible via TCP, HTTP, you can trace all of the trigger events in one place, which is your ingress or load balancer or whatever solution you're using. And this is the most valuable asset you have because it explains the root cause of anything that happens. And if you have it enabled, if you have the alerting configured, you are 95% ahead of everyone, even if you don't have QA team, even if you don't yet have stable application, if you have this enabled, it will be just a game changer for your reliability. So while logs and 500 observation can help improve the reliability, there is also a way to get good security insights. The next way to catch up vulnerabilities is again viewing into your logs. So now you have your logs enabled. Now you monitor your 500s, but there are another interesting events. Start monitoring 400 errors. Start monitoring origins of your request. Start monitoring DNS names of your request, and you'll find interesting patterns. I'm not telling you setting up alerting for everything, but at least reviewing the logs and getting the idea of what's going on will be really helpful. Well, potentially, if you find out some patterns, you can obviously create low priority notification about some events. But let me explain the example I've experienced in my journey. So I was configuring cloud infrastructure for one of the startup, and we got just released. We got the AWS load balancer. We had the logs enabled, and the application just started. Just had 2 clients, so really not big traffic. And I started noticing that there are lots of logs going on. I was considering there might be health checks, so I started digging in. And what I found that there were lots of requests targeted not by the DNS name of my services, but actually by the IP addresses that provided by Amazon under the hood. And these requests were targeting the path of some common configuration file extensions like Java config files, PHP config files, anything like that, any files that might contain sensitive data. And he started warning me, who is doing this request? And I was thinking that they are doing continuously. And I started digging into the source IP address, and I found that the IP address was belonging to Google. So my initial thought was maybe AWS has some internal crawlers assuring the security of my application and doing these checks. But when I found the source IP address of Google, it makes me feel cautious. So what I realized later on, that these were some random bots that were configured somewhere, maybe on the Google infrastructure, maybe on some VPN. They were just brute forcing all AWS IP addresses. If they found some IP address available, they were just randomly trying to get different config files, because there might be some people who don't know how to deploy properly, don't know about security, and they might expose PHP config files, database credentials available by this path. So they just get this credential connected to that database, stealing the data, doing anything they want. So that was a really great security insight I have found. Obviously, my system was returning for all of these responses, so they haven't get anything meaningful, but still it just allowed me to see these issues. So I was able to configure WAF rules for such a behavior, and also configure some minor monitoring to see if any patterns of 401 spikes will increase. Then I will be able to take the respective action. So the takeaway for this reason would be, first of all, if you not have your logs enabled, please enable them for your load balancing ingress. It will change your life, as I already told you. The second one, have a practice of regularly reviewing them by focusing not only on 500s but also 400s and some unusual requests. If you know that all of your API traffic comes from your web application, and you know that your application is always communicate to your services via your DNS name, your endpoint, try to search some requests that are not using DNS name, that targeting directly by IP address. They might be really interesting, or any patterns like this, any unusual behaviors. And this will help you to basically understand the security level of your application and let you spot these small security attacks earlier, even before they have an effect. Additionally, if you, I would suggest to setting up the alerting for 400 rates similar to 500. If you have, let's say, more than 10% or than 1% in 400, that's useful. It's not the highest priority, obviously, because you don't need to distract your team from working on more important issues when you have 400 spike. It might though indicate something or aided some issue on the application or some attack. But as far as your application built on the solid security foundations, there should be any issues with that. And in the end of the day, if you spot this issue, just solve them that. Just create WAF rules. Just think about which steps you can take to prevent these attackers. choosing application. But this way just opens your eyes on what's going on the security side of your system and either any attacks or not. Then the third way, which is really fundamental for me, that can just change the way how you solve issues, how you fix bugs, and how you do anything in your application, is traceability. And again, traceability is a really abstract term because it involves your visibility over all applications. So if you have your logs enabled for your load balancer, for your ingress, whatever you're using, you already have a good observability, right? But it's not just about this. It's about the fact that you can combine different log sources together and find out the entire lifetime of the event that happened and what triggered them. Let me give you an example. So when the request comes to your endpoint, it hits your request proxy. Is it load balancer, ingress, whatever. So in case with AWS load balancer assigns the trace ID header to the request and then forwards it inside the application. So then when the application makes a logs, it's important to include this trace ID, which is UID string, to your log entry. And any remaining application, if you have a complicated distributed system and there is one application that calls another application that calls another application that makes a database call, something like that, make sure you forward this trace ID to all of the subsequent calls and include them to your logs. Why? Because at the end of the day, let's say your database request fails for some reason, and you found this request uses some kind of weird query parameters, anything like that, you can trace the root cause of this request, like the trigger of this request. So basically, you see the log that this request has been made, you see the trace ID, and you just, in your logs aggregation system, takes all the requests together and filters them by this trace ID. So when you filter them by this trace ID, you can see the logs from all the subsystems, and you can get up to your reverse proxy ingress load balancer logs and see what triggered that request, who triggered it, which time it was triggered. You can troubleshoot it further. So the traceability is a huge benefit of having logs enabled for your reverse proxy load balancer, as well as properly propagating the trace ID header, and obviously using the centralized logs monitoring. So these are the 3 ways that will change your life dramatically. Start using them today and you won't regret. So the next question is how you configure it, right? It depends on which solution you're using. You might be using AWS load balancer, as I did a couple of times. You might be using Google Cloud Platform. You might just have the self-hosted deployment with your Nginx or proxy, whatever. The important thing is to configure them. And what I would say that most of the solutions have this configuration built in, and it's really straightforward. In Google Cloud Platform, you have your load balancer, you have your application, you just click enable logs and your logs will appear in your cloud monitoring logs. Straightforward. In Azure, when you configure ingress for your container apps deployment or for Kubernetes, it's straightforward. When using Kubernetes with Nginx ingress, it's also straightforward. However, when using AWS, and I know most of people using AWS, and I used AWS a lot, and using load balancer, this is where it becomes really tricky. So AWS didn't make it that obvious and easy to configure these logs. So here's what you need to do. So with AWS, they do not support direct load balancer logs streaming into CloudWatch, which is super weird for me. I don't understand this. Well, I know that they are motivated by their own system design, and they more cared about how software engineers feel about their product rather than how the user that will use the AWS feel about it. But it just still doesn't make sense for me. So by default, you can configure AWS logs to be stored in S3 bucket. It's ridiculous, right? So AWS will aggregate logs by chunks and throw it into the files into a bucket. So we need to create bucket, we need to configure a load balancer to be able to write logs to the bucket. And it's done, right? No, because how you read these logs? This is another question. So the first idea that comes to your mind, just open the files in your S3 bucket. That's a disaster, don't do it. You never find anything. Imagine you downloading the bucket of the S3 logs locally and using some commands you like to search. No, don't think about it, that's rubbish. So what AWS proposes by default in that documentation they proposing using AWS Athena. Ta-da! So let's create complexity, token complexity for the thing that should be done in one click. That's the strategy of AWS probably. So you need to create Athena database. What is Athena? It's basically the way to query the content of your S3 files. So you can turn your S3 into a database and make SQL queries to that. But it's not just about Athena. It's also about that you need to continuously parse your logs, right? And in order to parse them, you need to configure glue crawler. And the glue crawler is like an instance of Apache Spark managed by AWS, where it just continuously crawls your S3 files and keeps them, maintains the schema of the database, right? So that when Athena has a schema, you can query them. So to have simple logs in AWS load balancer, you need create bucket, configure permissions from load balancer to bucket, configure permissions from glue crawler to S3 bucket, create Athena, configure permissions from Athena to S3 bucket, and only then you can start querying. Well, how to query them? Then you need to add an SQL query. You can save the query in SQL. And now it appears that all of your applications running in CloudWatch are having logs in CloudWatch. And suddenly the load balancer applications, the load balancer logs appear in Athena. That's super unusable, super ridiculous. I don't like AWS for that, but this is what we have. And I don't want to be down in the deep details how to configure it, but this is the overall process. I'll create another video how to do it, so stay tuned and please subscribe if you don't want to miss it. But there is another way how we can do it better. And better, these logs will become more usable, because it is still complex, but at least they become more usable. So what I'm personally doing, I'm creating the AWS logs. I want to create in the CloudWatch. Why? Because let's say all of my logs for all my deployments in CloudWatch, and I want to have the centralized way to query them. So how to do it? The good thing is that I don't need to use the glue crawler and Athena for that. I'm still figuring logs storing in S3 bucket for my load balancer, but now I'm creating a Lambda function. This Lambda function has an event configured from S3 bucket. So whenever the file to your S3 bucket is uploaded, it triggers the Lambda function. So Lambda function gets notification about the file that load balancer puts into S3 bucket. It then downloads this file and pushes it to CloudWatch. Yes, still complicated. You need to manage Lambda function, pain in the butt. But from my experience, this approach worked much more reliably than Athena. I was using Athena for a while, and then suddenly, after half a year, the Athena query stopped working. I don't know why, just something happened in the glue crawler or anything, it stopped working. I become mad, and I just wipe it off and choose the Lambda function. So this approach might be more costly because you're paying for Lambda, but I was calculating, so if you have 1,000 requests per minute continuously, and logging this request to CloudWatch with Lambda function will result in an additional $20 Lambda bill per month. And you can only imagine that 1,000 requests per minute, that's a lot. That's really high traffic. That's on average 100% a minute. So that's a lot, that high traffic that probably most of the higher giant brands have such much traffic. So I think they definitely can afford $20. And if your application is low scale, the price will be neglectable. And I think you'll even fit in under the free tier Lambda execution limits. But as a result, you will have them in your CloudWatch. If you're not using CloudWatch, if you're using Grafana, Loki, or whatever solution you use for some reason, but you're still using AWS Load Balancer, you can do the same literally with Lambda. You can make the Lambda throw the logs directly into your solution, or if you're using some metrics collector, you can integrate metrics collector there. So this is the 3 ways how you implement it in the AWS. And I'll create another in-depth tutorial about how to do it step by step and share all the source code with your infrastructures code, Lambda code and everything in my next video, so make sure to subscribe to not miss it. So that's really usable, but the problem is AWS make it complicated. And it's not just about AWS. There are lots of different use cases and tricks when it comes to simple things that we expect to be out of the box, where they are overcomplicated by cloud providers. And it's great if you know them. That's why I want to share them with you. But there are probably lots of things you don't know and want to know. It's good that you have an experience and you can just judge from experience. But what to do if you don't have an experience and you want to learn and you want to understand how it works? I was thinking about it, and I've decided to create my Cloud Deploy AZ program. So this program is not yet released. I'm only creating it. But this is where I'm going to share with you the entire process, entire philosophy of how to deploy applications to the cloud, as well as the step-by-step deployment tutorials with infrastructure as a code, modules, and everything for Google Cloud Platform, Azure, and AWS, Kubernetes, and even if you want to deploy to your local virtual machine. So I'll share with you all the skills and knowledge I have. But not just about this. It's not just about knowing how to deploy. It's also about knowing why you should deploy, why you should choose AWS over GCP, why you should choose AWS Elastic Container Service over Elastic Kubernetes Service. Should you choose Fargate or should you go with EC2? Maybe you just don't need cloud at all, you can deploy to virtual machine. There are a lot of decisions to make. Should you use CloudWatch or should you use Grafana? Lots of decisions, lots of tools, and you might be overloaded. There are some industry standards, but each use case is specific, and it's not possible to have one solution that will suit for all. For that reason, I'm designing this program in the way that will not only teach you how to do things and answer how question, but also explain you why you should do things this way. It will provide you this step-by-step guided framework that will let you understand, analyze, and create your crafted, unique infrastructure that suits to your solution depending on your business requirements, on your team style, on your team size, on your budget situation, and all the other constraints you might have. So it's not about everything fits all. It's about for you to first of all making a decision what do you need, and then learning how to do it following all the best practices, yet being maintainable, cost-effective, secure, and reliable. At the end, you'll be able to build your crafted, tailored solution using the resources, modules, and code that I will provide, like Lego blocks, to create a unique deployment, infrastructure development operations, keep your application secure, reliable, maintainable, and cost-efficient. So if you're interested in joining this program, it's not yet released, but right now you have the opportunity to become an early adopter and get the benefits by joining the program in the Massive Discount and getting specific consultation and support. So if you're interested in joining this program, please follow the link below and join the waitlist. This is where I'll keep you posted about the progress and will let you know when the early adopter pre-sale will become available and keep you posted with all the updates regarding the program. So don't hesitate, bring your infrastructure to the new level, follow the link below, join the waitlist, and I'll see you there.